Okay, this is section 5.3, the first part of section 5.3. We're going to be solving trig equations, and they're going to expect you to remember two main concepts: how to factor or how to simplify trig expressions or equations, kind of like what we've been doing on 5.1 and 5.2, so how to rewrite them using identities. And then they combine that with, after we solve, we have to figure out at what angle these values that we get as our answers, what angle those values occur at. Okay, so we've done all of this before, but it's all just kind of connected together in one section. So example 1 says, I want to solve 2 sine x minus 1 equals 0, and the answers that we want are going to be between 0 and 2 pi. Okay, well, we have to look at this as a regular, just algebra equation. I want sine x by itself. So the first thing I'm going to do is I'm going to add 1 to both sides. So I have 2 sine x equals a positive 1. So if I want to get sine x all by itself, then I have to get rid of the 2, and I get rid of that 2 by dividing by 2. So I get sine x equals 1/2. Okay, so now our answer is going to be, at what value or at what angle is sine equal to 1/2? And we only want our answers in this problem from 0 to 2 pi. Well, some of you may have that memorized from your unit circle. Okay, if you don't have it memorized, here's what we're going to do. I know that sine is a positive number in the first and second quadrants because of all students take calculus. So I'm going to draw my triangles in these two quadrants. Okay, we also know that sine is my y value over my hypotenuse, or opposite over hypotenuse. So if this is my angle right here, opposite is 1, hypotenuse is 2. If this is my angle, opposite is 1, hypotenuse is 2. So when I use Pythagorean Theorem, we don't even really care what this other number is. I just want to know, is this a 30-60 triangle or is it a 45-45? Well, when I use Pythagorean Theorem, this other side is going to be the square root of 3. So I know this is a 30-60 triangle. My goal is to find out what this angle is. Well, I always look for my 1 because my 30-degree angle is always opposite 1. And so I know this is 30. So I know this is 30. Now my answers that we want will be, we always start on our x-axis and we're going to go up until we reach our hypotenuse. So my first answer is 30 degrees. I'm going to do the same thing. I'm going to start here and we're going to go until we hit our other hypotenuse. That's the angle that they want. So if I know this is 30 degrees, this angle has to be 180 minus 30, so that's 150 degrees. So my two answers are 30 and 150, but we always want to write our answers in the same form as what they give our intervals. And if they don't give us an interval, we're always going to write it in radian form. So we're going to change these to radians. 30 degrees is pi over 6. And 150 degrees is 6 pi over 6 minus pi over 6. So that's going to be 5 pi over 6. So those are our two answers, pi over 6 and 5 pi over 6. Okay, let's do another one. Example 2. Find all solutions of sine x plus the square root of 2 equals negative sine x in the interval from 0 to 2 pi. Now notice I have a bracket here and a parenthesis here. The bracket means I can include 0 as an answer if I need to. The parenthesis means I cannot include 2 pi as an answer. Okay, so the first thing we want to do in this problem, I want my sine x's all on one side, everything else over on the other side. Okay, so let's move this sine x over with this one. So I'm going to add sine x to both sides. So I have sine x plus sine x. That gives me 2 sine x's plus the square root of 2 equals 0. Okay, I need to subtract the square root of 2 from both sides because I want sine x all by itself. I did this problem the long way. I Just looked at it, that's okay. Divide by 2. So I know sine x is equal to negative square root of 2 over 2. Okay, so what I'm looking for, I want to know at what angle between 0 and 2 pi is sine negative square root of 2 over 2. Well, some of you may already know that without looking at your unit circle. But if you don't know the answer, here's what we're going to do. I'm going to draw my triangles. I'm going to draw my triangles in the quadrants where sine is negative. All students take calculus. So sine is positive in the first and second quadrant, so I'm going to draw my two triangles here. We know that sine is opposite over hypotenuse, or y over r. So I'm going to label this triangle. My y value is negative square root of 2, and my hypotenuse is 2. If I were to do the Pythagorean Theorem, this other side is square root of 2 and square root of 2. So I'm mainly concerned about what kind of triangle I have. Do I have a 30-60 or a 45-45? I know that I have a 45-45 because I have two legs that are the same, square root of 2 over 2. Oh, I'm sorry, square root of 2 and square root of 2. So I know I have a 45-45. So this angle right here is 45. This angle right here is 45. So remember how we want our answers. I always start on the x-axis, go counterclockwise, and I'm going to keep going until I reach the hypotenuse. Hang on one. Okay, so I forgot what I just said because I had to pause it and leave for a second. But we want to find this first angle. So I'm going to go start here, go all the way till I hit my hypotenuse. And so that's going to be 180 plus 45. So that's going to be what, 225? And then all the way around again till I hit this hypotenuse. So that's going to be 360 minus 45, or 315. Now, if you don't want to have to write down your angles in degrees first, then that's fine because we're going to write our answers in radian form. So 225, let's see, that's going to be 4 pi over 4 plus pi over 4. So that's 5 pi over 4. And then 315, that's going to be 8 pi over 4 all the way around. So that's 7 pi over 4. Okay, if you've forgotten how to do this, changing degrees to radians, you need to let me know. Okay, changing degrees to radians, you're going to multiply by pi over 180. Okay, so that's example 2. Example 3. Example 3, I have to solve. This time they did not give me an interval. So we're going to talk about that. Let's go ahead and solve this first. I want tangent all by itself, so I'm going to add 1 to both sides. 3 tangent x equals 1. Then I have to divide by 3. So I have tangent squared x equals 1/3. And then I have to take the square root of both sides. So when I take the square root of tangent squared x, I get tangent x. And on the right-hand side, I get plus or minus. You have to make sure and put that plus or minus in front, or you're going to miss some of your answers. And then the square root of 1 over 3, which ends up being plus or minus 1 over the square root of 3. You can rationalize, but I'm not going to. So I want to draw my triangles where tangent is positive and negative, which would be all 4 quadrants. Now here's the thing though, before I draw my triangles, let's talk about, since I don't have an interval, that means since all my trig functions are periodic, and that means, remember the period for sine is 2 pi, so after 2 pi my answers start repeating themselves. Okay, same thing with tangent, but the period for tangent is not 2 pi, the period for tangent is pi. That means if I just find my answers from 0 to pi, then they're going to repeat themselves. Okay? So, let's draw our triangles just in the first 2 quadrants. Because remember, this is 0, this is pi over 2, and this is pi. So I only need to go from 0 to pi. So my 2 triangles, tangent is y over x, or opposite over adjacent. So I know that my opposite side is 1, My adjacent side is the square root of 3. When I use Pythagorean Theorem, I'm going to get 2. So I have a 30-60 triangle. Okay? I always find opposite my 1, so this is 30 degrees, this is 30 degrees. All right? So let's write down our first angle. My first answer is 30 degrees, or 30 degrees is pi over 6. My second answer is 180 minus 30, so that's 150, or 5 pi over 6. Now here's the deal. It's pi over 6 and 5 pi over 6, but then it's going to repeat every pi. Because tangent, the period is pi, my answers are going to start repeating, and they didn't give me an interval to write my answers. So it's going to be pi over 6 plus every pi after that. So we're going to write that as pi over 6 plus pi k. And then same thing with 5 pi over 6. It's 5 pi over 6 and every pi after that. So those are my two answers. Okay, example 4. All right, cotangent x times cosine squared x equals 2 cotangent x. Okay, so the first thing I see here, I have something squared, so it means it's quadratic, which when I'm solving quadratic equations, we always want to set it equal to 0. So I'm going to subtract 2 cotangent x. So I have cotangent x times cosine squared x minus 2 cotangent x equals 0. So now I'm looking at this to see how I could solve. I do notice that they each have a cotangent x in common. So I'm going to factor out a cotangent x, and in parentheses, I'm going to write down what I would have left. I would have a cosine squared x minus, and if I factored this out, I would just have a 2. So remember, whenever back in algebra, if I have something factored like this, I have 2 factors, I can set each factor equal to 0 and solve. So that's what I'm going to do. Okay, so let's look at cotangent x. Where is cotangent x equal to 0? Okay, well, first of all, I know this is 0 over 1. I know I can't draw a triangle because I can't draw a triangle with the length of 0. And so this must occur at one of my points, a quadrantal angle. So we should remember that cotangent is x over y. So remember, this is the point 1, 0, 0, 1, negative 1, 0, 0, negative 1. So where is my x value 0 and my y value 1? What happens right here? So my answer for this one is pi over 2. Now, again, they did not give me an interval, so I know it happens at pi over 2. I solve for cotangent. What is the period for cotangent? The period for cotangent is pi. So it's going to be pi over 2 plus every pi after that. So there's the answer for that part. Now I have to do the work for this part. So I'm going to solve for cosine squared x. So cosine squared x equals 2. I have to take the square root of both sides. So that means cosine x would equal plus or minus the square root of 2. All right, well, here's the problem. Okay, I know that cosine is adjacent over hypotenuse. So when I draw my triangle, my adjacent side would be the square root of 2, and my hypotenuse would be 1. The problem is the square root of 2 is bigger than 1. Square root of 2 is 1.414. So do you see that my hypotenuse is smaller than my side, and that can never happen? So this part is not possible. So I only have one answer, and it's pi over 2 plus pi k. Okay, example 5. Find all solutions of 2 sine squared x minus sine x minus 1 equals 0 from 0 to 2 pi. The brackets mean if 0 and 2 pi are an answer, then I can include them. So this is a quadratic equation. It's already set equal to 0, so I must be able to factor this. So I know I'm going to have 2 sine x and sine x. I know my signs are different, as my largest number will have a negative next to it. But my largest number is always 1 anyway. So I have 1 and 1, so it's going to be minus and plus. Because 2 sine x times negative 1 is negative 2 plus 1 gives me my negative in the middle. So now that I've factored, I'm going to set each factor equal to 0. And now I'm going to solve. 2 sine x equals negative 1. Divide by 2. And I get sine x equals negative 1/2. On this one, I'm going to get sine x equals 1. So let's look at this one first because this one's going to be easy. Again, sine is opposite over hypotenuse. So this is 1 over 1. Do you see that my hypotenuse would be the same as my length of my side? That can never happen, so I know this part's going to have no solution. So I don't have to worry about an answer for this. Now, I do have values where sine x is equal to negative 1/2. So if you don't know what those are, and again, they gave me a limited interval, so I don't have to worry about pi k and things like that. I'm going to draw my 2 triangles where sine is negative. So all students take calculus. That would be in the 3rd and the 4th quadrants. We know that sine is opposite over hypotenuse, or y over r. So my y value is negative 1 and my hypotenuse is 2. If I want to use the Pythagorean theorem, I can, just to figure out what kind of triangle I have. I know that I have a 30-60 triangle. So there's my 1. So I know this is 30 degrees, which means this is 30 degrees. Now my answer will start on the x-axis and go all the way around until I hit my hypotenuse. So this angle all the way around is going to be 180 plus 30, which is 210. Or 210 is 30, sorry. Pi over 6, so 6 pi over 6, that's going to be 7 pi over 6. Then my other angle is going to start here, go all the way around, so that's 360 minus 30, so that's 330. Or 12 pi over 6, which is 11 pi over 6. Oh, I need to fix something really quick. Oops. 11 pi over 6. Go back and look at this. Sine x equals 1. I just had a brain freeze here. I can't draw my triangle. Yeah, that's right. I was thinking, where's my y value 1 is a quadrantal angle. That's not right. So no solution is the correct answer for that part. Okay, 2 more examples. Example 6. All right, so example 6. Oh, here's a problem with this one. The problem is it's already set equal to 0. It's quadratic, but I need these to be the same thing. Okay, I can't deal with sines and cosines. They all have to be the same. So do you see that sine squared? I can rewrite sine squared as 1 minus cosine squared. Okay, so I'm going to replace this with 1 minus cosine squared. So I have 2 times the quantity 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. So now I'm going to distribute my 2. 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. So I'm going to combine my 2 and my negative 3. So I have negative 2 cosine squared x plus 3 cosine x minus 1 equals 0. And now I have a quadratic equation. I can factor it. Here's the deal. I don't like negatives in front of my first coefficient, so I'm going to multiply everything by negative so I can get rid of that. Cosine squared x minus 3 cosine x plus 1 equals 0. So now I'm ready to factor. I know my signs are the same because of this right here, and they are negative. So I have 2 cosine x minus cosine x minus, and I know it has to be 1 and 1. Set each factor equal to 0. 2 cosine x minus 1 equals 0. Cosine x minus 1 equals 0. So 2 cosine x equals 1. Cosine x equals 1/2. And then I have cosine x equals 1. Okay, so let's do cosine x equals 1/2 first. If you don't know where cosine is equal to positive 1/2, I know my triangles will be in quadrant 1. All students take calculus in quadrant 4. Cosine is x over hypotenuse or adjacent over hypotenuse. So it's 1, 2. When I use Pythagorean Theorem, I get square root of 3. So I know I'm always looking for my 1. That means this is 60. I'm sorry, this is 30, so this must be 60 degrees. And this must be 60. So my first answer is 60, or in radian form, that's going to be pi over 3. Now, they did not give me an interval. I know that the period for cosine is 2 pi. So my answer must be pi over 3 plus every 2 pi after that. Okay, then I'm going to go over here, keep on going until I hit my hypotenuse. So that's 360 minus 60, so that's 300 degrees. Or in radian form, that's 6 pi over 3 minus pi over 3, which is pi over 3, plus every 2 pi after that. Okay, so now we're going to do this one. Cosine x equals 1. And I stopped in example 5. I made a mistake right here. There is a solution. I knew I wasn't looking at it right. Okay, see if you can go back and find where is sine x equal to 1. Okay, your hint, sine is your y value on your unit circle, so tell me where your y value is 1. So my mistake, I knew something wasn't right there. Okay, so look at this. Where is cosine, which is my x value, positive 1 on my unit circle? Well, at this point, oops, 1, 0. That's the point 1, 0 where my x value is positive 1. So it must be 0 and then every 2 pi after that. So 0 plus 2 pi k, that would work. Last one, example 7. Solve cosine x plus 1 equals sine x in the interval from 0 to 2 pi. Again, I can include 0 and 2 pi as an answer if I need to. All right, so here's a problem. They're not in the same term, so one needs to be cosine or they all need to be sine. There's nothing squared, so I can't use an identity. So on this problem, this is a special type of problem, and when you have these on your assignment, I'll kind of tell you what you need to do. I'm going to square both sides. So here's what it's going to look like. Cosine x plus 1 quantity squared equals sine squared x. So now I need to FOIL this out. So I'm going to write it out. Cosine x plus 1, cosine x plus 1 equals sine squared x. Now I'm going to FOIL this out. So when I FOIL that out, I get cosine squared x plus 2 cosine x plus 1 equals sine squared x. And now do you see that everything's in terms of cosine except for this side? So I need to rewrite this side in terms of cosine. Well, we know that sine squared x is equal to 1 minus cosine squared x. So I'm going to rewrite it. Cosine squared x plus 2 cosine x plus 1 equals 1 minus cosine squared x. Now I have a quadratic equation, so I need to set it equal to 0. So I'm going to move all this over. So when I add cosine squared x, I get 2 cosine squared x plus 2 cosine x. When I subtract 1, I get 0. So these ones cancel each other out. Now to factor this, I notice that they each have a 2 cosine x in common. So I'm factoring out a 2 cosine x. In parentheses, or what I would have left, is cosine x plus 1. So they want to know, well, first of all, I'm going to set each of those factors equal to 0. So when I solve this one, divide by 2, and I get cosine x is 0, and cosine x is negative 1. Okay, so these are all going to be quadrantal angles. So I'm going to go ahead and put my points on there just to kind of remind you. They want to know at what angle is cosine 0. And this is negative 1, 0, 0, negative 1. So where's cosine 0? Well, cosine is 0. Cosine is my x value at pi over 2, right here, and 3 pi over 2. Okay, so let's find out where cosine x is equal to negative 1. Cosine is my x value, so right here at pi. So those are my answers for example 7. Okay, I'll give your assignment tomorrow in class, and we'll work through any questions you have.